Okay, so I'm going to work out some pH calculations or some Ka calculations for weak acids. So with these acids, you could either reference a table that has some of the Ka information for it, for the acid constant, for how well it dissociates and how that would affect the pH. Or because you can't assume that it goes as a 100% or quantitative reaction. Okay, so what we will be using is the formula that says that the Ka is equal to the hydrogen ion concentration squared over the concentration of the acid. Okay, so for example, in this first question, the question asks for the pH of a solution where this is the concentration of formic acid and the dissociation constant is given. So as soon as a Ka is given, we cannot assume that the reaction is quantitative. What that means is we cannot assume that formic acid, the concentration of formic acid is equal to the concentration of H+. That is not true because it's a weak acid and it does not follow stoichiometry, for example. So if it's not going to be 100%, we can't make that assumption. So what we do know, we know that the Ka is 1.8 times 10 to the minus 4. We know that the concentration of the acid itself is 0.065 moles per liter, and we're trying to calculate the pH. Well, to get the pH, we need the negative log of the hydrogen ion concentration. And so how will we get the hydrogen ion concentration? We'll rearrange that guy right there. Okay, so acid times Ka, concentration acid, times Ka will give the H plus squared. And so we'll plug those numbers in and take the square root. So the acid concentration is 0.065. The Ka is 1.8 times 10 to the minus 4, and that will equal H plus if you square root the answer. When I plug all that into the calculator, it looks like you get 3.42 times 10 to the negative 3 as a hydrogen ion concentration. So we aren't done the question at that point. We still need to take a step and calculate the pH. To get that, we need to do the negative log of that concentration, 3.42 times 10 to the minus 3. So we take negative log of our answer, and I think you get a pH of 2.47 or so. Right? That would not be the answer you got if you just assumed that all of this became concentration of H+. You would get a different answer. This is a weak acid, so it doesn't all go to hydrogen ions. So you use the Ka formula when it's given there or when you've identified a weak acid. Okay, we'll look at the second question. Second question also wants the pH, and this time they give us an acetic acid concentration. So there's our concentration acid, and it is 0.325. The Ka was given, and we're looking for the pH, which means first we need the H. So we saw from our formula, if Ka equals the H plus squared over acid, then if we rearrange this formula for H plus, again, you get the square root of Ka times concentration of acid. So that's the square root of 1.8 times 10 to the minus 5 times the concentration of the acid, which is 0.325 moles per liter. And we'll plug that in. And after you take the square root, I have a hydrogen ion concentration, 2.42 times 10 to the minus 3 moles per liter. And so turning that into an H plus means you're going to, or sorry, turning that into a pH means you're going to take the negative log of that number, 2.42 times 10 to the minus 3. So we do negative log of the answer, and you get 2.62 as a pH. All right, so the next two ask the same deal, so 2.62 for that one. So here they want to know what's the pH of a solution that has this concentration of acid. So this is our concentration acid, and this is our Ka. And then you also have another concentration of a second acid and a second Ka. So if we use these two here, that will give us an H plus concentration. And then if we use the other two numbers, this acid and that Ka will give us a different H plus. And if we combine both of those H pluses together, we'll get the total, which then you can take the logarithm of. So we'll do this calculation in black first to get the H plus. We've seen the calculation a few times now. It's the square root of the Ka, 1.4 times 10 to the minus 4, times the concentration, 0.0034. Okay, and we'll see what that comes out to. It comes out to 6.8, now 6.9, I guess. 6.9 times 10 to the negative 4. And that's moles per liter. I'll switch to red to do the other numbers. So to get the other H plus concentration from the second bit of information, the square root of its Ka, which is now 1.4 times 10 to the minus 5, times the concentration of 0.056 moles per liter, will give me a different hydrogen ion concentration, which if we round it off the same way, I guess you get 8.9 times 10 to the negative 4. Those two concentrations of hydrogen ion, that's how much stuff is in, how many H pluses are being contributed by each acid. So the total would be what you get when you add them up. Okay, so you get 14, so 15.8, so 1.58 times 10 to the negative 3. When you add those two numbers, I believe, that's your new total H plus. So now that you know the total amount of hydrogen ions present, you can easily calculate the pH of that total by doing the negative log of 1.58 times 10 to the minus 3. And you grab your calculator to work that out. Should give you a pH of 2.80. Now, you may want to figure out if you could take this pH and that pH and add them up. Well, take a second and see if you could work out each pH and see if indeed it adds up to give 2.80. And you'll find out if that's a rule that you can use. Okay, so final question to look at. We have a concentration of an acid here. We have a Ka given. Combine those two to get the H plus first. So we take the square root of that acid concentration, which is 3 zeros and a 5/6, and a Ka of 4.82 times 10 to the negative 5. Should be an awfully small number when you take the square root of that. After you take the square root, you get 1.64 times 10 to the negative 4 in terms of a concentration of moles per liter. And then getting the pH, take the negative logarithm of that number. So negative log answer gives 3.78. Okay, so still a fairly strong acid at those concentrations. Okay, so the long and short of this is to recall when you're dealing with weak acids, if you're dealing with acids that are on a table that could be given to you of weak acids, you can't just assume that the concentration of the acid is the concentration of H+. You have to use a formula to work that out, and I will hopefully be explicit enough when giving you those questions that you'll be able to know when am I using strong acids versus when am I using weak acids. Okay, so we're going to give you more questions to try. Good luck.